In this video, you'll learn how to solve the second type of word problem for linear equations in one variable. They're really not different from the ones we looked at in the previous video, so I want you to pause the video and try the first problem yourself. Done? First, we're going to model the context with a linear equation. The fixed part is 4.5, the repeating part is 2.25, the total is 24.75, so our equation is 4.5 plus 2.25x equals to 24.75. Then we simply solve the linear equation. We subtract 4.5, which gets 2.25x equals to 20.25, and dividing by 2.25, we get x equals to 9, so the answer is 9. The next one's essentially the same. Pause the video and try it yourself. Done? Here's my solution. The equation that models the context is 24 plus 12x equals to 120. I subtract 24, I divide by 12, and I get x equals to 8. So the answer is 8. Here's a variation on the previous problem. Please pause the video and try it yourself. This is how I would approach this. First, I'm going to establish a variable x, and x is going to represent whatever I'm trying to find inside the problem. Here, I'm trying to find the price of the scarf, so x is going to represent the price of the scarf. Now, I'm going to model a linear equation that uses x to find the value of x. Here, we see that Priya spent $50 on hats, which cost her $14, and she spent the rest of her money on scarves. So we can model a linear equation that goes like 14 plus 4 times x equals to 50. From here, we can just solve the linear equation to get x equals to 9. So the price of each scarf is $9. Now pause the video and try this problem yourself. Done? Here's how I would approach it. I'm going to set x as the length of each segment because that's what we're trying to find in the problem. And then I'm going to model a linear equation based off of it. Here we see that the introduction is 14 minutes long and that there are 4 segments of equal length, and we don't know that length. So we can model the total time of the documentary as 14 plus 4x. That's going to be the introduction plus the 4 segments. And that has to be equal to the total duration of the documentary, 90 minutes. From here, I solve the linear equation, and that gets me x equals to 19, so the answer is 19 minutes. Here's the next problem. Please pause the video and read it first. This problem requires a bit of a special approach. If you set t as the amount of time that the hot air balloon has been descending for, then you get to model a linear equation that looks like 132 minus x times t equals to 60. What is that x? That x represents how much the hot air balloon descends per second. Because if you multiply how much the hot air balloon descends per second by the time during which the hot air balloon has been descending, then you can find the total amount of distance which the hot air balloon has actually descended. Now the problem is we can't solve this linear equation to find t unless we know the value of x. But if you look towards the front of the problem, it tells you that the hot air balloon descends to 108 meters after 6 seconds. And so you can set up an equation that goes like 132 minus 6 times x, where x represents the amount that the hot air balloon descends per second, is equal to 108. From here, you can get that x is equal to 4. So the hot air balloon is descending at 4 meters per second. If you plug that back into our original equation, we get 132 minus 4t equals to 60. And solving for t, we get 6. So the answer is 6 seconds. Here's the next problem. Please pause the video and try it yourself. Done? First, I'm going to find the rate at which the water is exiting the tank. To do that, I'm going to use the information that's given at the front, which is that after 4 hours of draining, there was 30,800 liters of water left. From this, I can establish a linear equation, 36,000 minus 4x equals to 30,800. From here, I can find that x, the rate at which the water exits the tank, is equal to 1,300 liters per hour. Using this rate, I'm going to set up another linear equation to find for the time it takes for us to drain the tank to 19,100 liters. Then that's going to be 36,000 minus 1,300t equals to 19,100. Solving for t, we get 13. So the answer is 13 hours. Pause the video and try this yourself. Done? What are we trying to find in this problem? It's the height of the bamboo. So we're going to set that as x, and we're going to use a linear equation to solve x. We know that the initial height of the bamboo plus its change in height over the 16 days equals to its final height. So we can set up an equation that goes like x plus 16 times 2.5 equals to 58.3. Solving for x, we get 18.3. So 18.3 centimeters is the correct answer. Here's a very similar problem. Pause the video and try it yourself. Done? What are we trying to find? We're trying to find the initial amount of water inside the barrel. And we can set that as x, and we can create a linear equation based off the fact that the initial amount plus the change equals to the final amount. So we get the initial amount x plus the change 3.5 times 14 equals to the final amount 63.5, and solving for this linear equation we get that x is equal to 14.5, and so that is the correct answer, 14.5 liters. Here's the next problem. Pause the video and read it first. What are we trying to find for here? We're trying to find how long the drought lasted. So we're going to set that as x. And now we just need to find a linear equation which uses x. The most obvious linear equation here is going to be the initial water level minus the change equals to the final water level. That gets us 26 minus the change equals to 19.5. Now the change in water level can be written as the amount of change in the water level per day times the amount of days that have passed. How can we find how much the water level changes per day? Well, the problem tells us that the pond decreases by 1 inch every 5 days, meaning that the pond would decrease by 1/5 of an inch every day. So we can model the linear equation as 26 minus 1/5 times x equals to 19.5. Now pause the video and try this problem yourself. Done? What are we trying to find for? We're trying to find for how many days the tank has been in use. And what is the equation that we can set up? The initial amount of propane minus the amount of change in propane equals to the final amount of propane. So we get 40 minus the change equals to 29. And the change can be written as the amount of change per day times the number of days for which the propane has been in use. Now the amount of change per day is going to be 2/3 because for every 3 days, 2 pounds of propane decreases. So our linear equation is 40 minus 2/3x equals to 29, and solving for x, we get 16.5, which is the correct answer. Here's the next problem. Pause the video and try it yourself first. Here's how I would approach it. We're trying to find the number of sandwiches that the food truck sold. So we're going to set that as x. And we're going to establish an equation using what's provided, which is that profit equals to total revenue minus total cost. The profit is $306, the total cost is $150. So our first equation is $306 equals to total revenue minus $105. But this equation doesn't include x. So how can I modify this so that the total number of sandwiches which the food truck sold is reflected within the equation? Well, the total revenue is essentially the product between the revenue per sandwich sold times the number of sandwiches sold. So we can say that the total revenue is 8x. And so our final equation is going to be 306 equals to 8x minus 150. And solving for x, we get 57. So 57 sandwiches is the correct answer. Here's the next problem. Pause the video and read it first. Done? Here's how I would approach this. I'm first going to find the amount she earns for week 1. Then I'm going to find how much she earns on week 2. Then I'm going to set the difference, week 2 minus week 1, equal to 150, because we know that she earns $150 more in the second week than the first week. For week 1, Rena works for 38 hours, which is less than the 40-hour threshold, which means that Rena will be earning D dollars for every hour of the 38 hours that she works for. So her total earnings is going to be 38D. For week 2, she works for 44 hours. So for the first 40 hours that she works, she's going to earn D dollars per hour. But for the exceeding 4 hours, she's going to earn 1.5 D dollars per hour. So the total amount of her earnings is going to be 40D plus 1.5 D times 4, which gets you 46D. Now, if you find the difference between week 2 and week 1's earnings, that's going to be 46D minus 38D, which is 8D. And that has to be equal to 150. So the correct answer is going to be D equals to 18.75. Here's the last problem. Pause the video, solve it first, and then check the answers. I'm not going to be explaining this one because it's pretty self-explanatory. That's it for the second part of word problems for linear equations in one variable. As always, there are practice problems and notes uploaded on penguprep.com, so please go check that out, and I'll see you in the next video.